Hello students, myself Parthes Parekh. I am teaching maths and science in secondary level and I am also teaching physics and mathematics in higher secondary level, that is 11-12 science. So today we are going to discuss about the class 11 chapter number 2 units and measurement and its topic, that is the physical quantity. So first of all, here we know that what is the physical quantity and what is the fundamental physical quantities are there. Okay, so first of all we need to discuss about these things. Okay, so it is the property of a material or the system that can be quantified by measurement. Again we can read, it is the property of a material or system that can be quantified by measurement. Okay, so it can be expressed as the combination of the numerical value and its unit. Okay, so physical quantity is nothing but, suppose we take one example. Suppose I push some object, so I applied some force on the object. Suppose say I apply 10 Newton force on the object. Okay, so here 10 is nothing but it is the numerical value. And N is nothing but it is the unit of the force. Unit of the force. Okay. So physical quantity define the combination of the numerical value and a unit. Okay, so physical quantity expressed as the combination of numerical value and its unit. Okay, so here Newton is nothing but it is the unit of force. Okay, suppose we take another example. Say some object having a mass, say around 50 kg. Okay, around 50 kg. So here 50 is nothing but it is the numerical value and kg is nothing but it is the unit of the mass. Okay, so that's how we can express the physical quantity. Okay, now any physical quantity represent as the combination of 7 fundamental quantities. So what are these 7 fundamental quantities? So students, here we need to know the 7 basic fundamental physical quantity, that is length, the symbol is L, then mass, the symbol is M, time, the symbol is T, then thermodynamic temperature, and the symbol is K, then fifth one is electric current, the symbol is ampere, means A, then sixth one is luminous intensity, symbol is candela, and the last one is quantity of matter, so the symbol is mole. So this is how we can define these 7 basic physical fundamental quantities. Okay, so here the symbol is given and the physical quantity is also given. Now students, we define the dimensions of the different physical quantity. Okay, but first of all we need to know what is dimension. Okay, so dimension is nothing but it is the power or the exponent to which the base quantity raised to its called the dimension of the quantity. Suppose here we define the volume. So the formula of the volume of the cube, that is length, breadth and height. Okay, so length is measured in meter, breadth is also measured in meter, and height is also measured in meter. So meter into meter into meter is meter cube. Okay, so here the power is 3. So here we can see that the dimensions of this physical quantity is 3. Now the another thing is that we need to write the dimensional formula of the different physical quantity. So the dimensional formula is nothing but it is the expression shows how and which of the base quantity represented the dimensional formula of the physical quantity. Okay, so here we can write different derived physical quantity from the 7 fundamental physical quantities. Okay, so first of all here we can write the speed. So speed is nothing but it is the distance divided by time. So here we can write its equation, that is distance divided by time. Okay, so we know that the distance measured in meter and the time measured in second. So we need to write here the SI unit of the speed. But here what is SI unit? So it is the internationally accepted units. Okay, so the full form of the SI unit is System International, means internationally accepted unit. Okay, so here the unit of the speed, that is meter per second. Meter per second. And the dimensional formula here we can write in MLT form. M for mass, L for length and T for second. But in SI unit of the speed, the mass is not here. Okay, so here we need to put 0 power on the mass. Okay, so here we can write the dimensional formula of the speed, that is m raised to 0, and the distance measured in meter. So here L is present, so L raised to 1 and T raised to -1 because S is in denominator, that's why. Okay, so this is how we can write the dimensional formula of the different physical quantities. Okay, in bracket we can write. Okay, now we need to define another physical quantity, that is derived physical quantity from the fundamental physical quantity. Okay, so the another physical quantity, that is acceleration. Acceleration. So we know that the acceleration formula, that is the change in the velocity with respect to time, it gives the acceleration. So here we can write the acceleration formula, that is change in velocity with respect to time or in unit time. Okay, so we know that the velocity, the unit of velocity, that is meter per second. So here we can write the unit of acceleration, that is the change in velocity, that is means velocity measured in meter per second and time measured in second. So second going to the denominator side. So here we can write meter per second square. Okay, so the SI unit of the acceleration, that is meter per second square. Now we need to write the dimensional formula of the acceleration. So it is came from this, that is m raised to power 0, because here mass is not present, that's why. So here we put 0. Okay, and L raised to 1 and T raised to -2. Okay, now we define another physical quantity, that is force. Okay, so force is nothing but it is according to the Newton's second law, that is mass into acceleration. Mass into acceleration. Okay, so mass measured in kilogram and acceleration measured in meter per second square. We already seen that. Okay, so here the SI unit of the force we can write, that is kilogram meter per second square. Okay, and the dimensional formula of the force, that is m1 L1 T raised to -2. We can define or derived, we can write the dimensional formula of the any physical quantity from its units. Okay, so we need to know all about the units. Okay, so here we can write the dimensional formula of the force, that is m1, because kg here is given, that's why. Mass here is m for length, so that is L1, and t raised to minus 2. So that's how we can write the dimensional formula of the different derived physical quantities. Okay. Now we take another derived physical quantity, that is work. So the unit of the work came from the formula of the work done. Okay, so work done is nothing but it is the force into displacement. Force into displacement. So F is force and D is nothing but it is the displacement, okay, of any object. Okay, so force is measured in force measured in Newton, and displacement measured in meter. So the dimensional formula of the work done, that is Newton into meter. But another unit we can also write, force is also, we can write F equals to ma from the Newton second law, and D is nothing but it is a displacement. So here we can write kilogram, mass is measured in kilogram, acceleration measured in meter per second square, and also here D is given. D is nothing but it is the displacement. So displacement measured in meter. So totally we can write the dimensions SI unit, that is kilogram meter square per second square. Now we easily write the dimensional formula of the work done. Okay, so here we can write the dimensional formula of the work done, that is m raised to 1, L raised to 2, T raised to minus 2. Okay, that's how we can easily write the or find out the dimensional formula of the different physical quantity. Okay. Now we see the another physical quantity, that is the power. Okay, it is the power. This is the work done. So power is nothing but it is the work done per unit time. Work done per unit time. So we already know that the what is the formula of the work done, that is the F into D. So here we can directly write the SI unit of the power, that is work, means work done is measured in the SI unit of the work done, that is kilogram meter per second square. Also we can write joule. Okay, so here we can write kilogram meter per second meter square per second square divided by second. So ultimately the SI unit of the power, that is kilogram meter square per second cube. Okay, so the dimensional formula of the power, that is m1 L2 T raised to minus 3. So that's how we can define the different derived physical quantities and its dimensional formula and its SI units from the 7 basic fundamental physical quantity. Okay, so thank you everyone. Hope you like my video.